We're just going to roll through the definitions. This will be posted, I think. All right. You guys ready? You got a writing utensil? We're going to go pretty quickly here.
Wait.
This is our last unit of the year, guys. And we've studied, most of the year we've studied lines, right? Lines are called linear functions. We're going to, hey guys. No, this is actually called a quadratic function, which makes a parabola. It looks like a cube. Okay? And these model in real life any kind of projectile motion. So if you guys know all about projectile motions, every time you shoot one of your pieces of paper that you wadded up into the trash can, that can be modeled. You ready? That can be modeled with a quadratic function. If you shoot, any of you guys go shooting, right? Bullets. The path of a bullet is actually a quadratic. It doesn't seem like it. It seems like it's going straight, but it's not. It's falling, right? So it's quadratic. A rocket being shot in the air, anything, a football being punted, soccer ball being kicked, all of that is quadratic function is what models it. Even somebody jumping out of an airplane, that's modeled by a quadratic function. Okay? Seems like they're just dropping vertically, but that's modeled by a quadratic function. So they're huge in real life. We're going to study them just a little bit. But it's a function of degree 2. That means it has an x squared in it. Okay? Degree 2. So function with a degree of 2. So you're going to need to have your writing utensils ready. We're going to go through these pretty quickly. Okay? I'm going to kind of reveal them all, and then I'll give you time to get caught up, and I'm going to pause the recording. Okay? So standard form is y equals ax squared plus bx plus c. Does this look kind of like what we've been working with lately?
No.
Has an x squared, an x, and a number.
Yes.
What's that called?
Yeah, what's all three? I don't remember.
Has 3 terms. That's what you started on before your bicycle.
Trinomial,
yeah.
Trinomial.
And so they look like this. They look like what we've been factoring. As a matter of fact, the way you solve a quadratic, one of the ways is to factor it, to solve it. So that's why we've been learning factoring, is so that we can solve a quadratic. And when you find solutions to quadratics, here's what you're thinking. The place where the missile was launched and the place where it, yeah. So, yeah. Okay, next term, a lot of terms here, is a parent function. A parent function is the simplest quadratic. The kids become a little more complicated, but the parent function is a simple quadratic. And the parent function for all of quadratics, all of the ones we're going to be focusing on graphing, is y equals x squared. That's the simplest one. It has no x attached, no constant, no number. It's y equals x squared. So the simplest quadratic. Did you get that down? Yeah. Write that down. And I will leave this up here. I'm going to roll through them pretty quickly. Okay. Parabola is the shape of a quadratic graph. It's a U shape. So you might even want to just write U shape. Okay. A parabola is a U. And it can be, well, it could be an N if it's facing downward. Okay. Think about a missile being launched. It's really an upside down parabola. So it's more like an N than a U. But we call it a U shape. So parabola is what the graph of a quadratic function looks like. Yes, sir.
What multiplies to 30 by x and 13?
You got to start going through it. So here's what you want to do. You do it. Start listing them all. Start listing them all. 1 and 30, 2 and 15, and 3. Start listing all of them. You'll see it. Axis of symmetry is the line that cuts the parabola in half. So people have an axis of symmetry, right? Like we're basically a mirror. If you cut right down the middle, or well, more or less, we're not terribly symmetric, right? But a lot of us have. They are. Lots of things in life are symmetric, but people are generally symmetric. I know that my right foot's a little longer than my left. I at one time broke my left foot, and so I think that might have affected it, but it could have been like that anyways. But 2 different thumbs. So we're generally symmetric. We have some flaws. Even Trevor has an Achilles heel. He's not perfect, but nearly. So axis of symmetry goes right down the middle. It's the place where, guys, you could fold over the parabola and match it up. Okay, so the axis of symmetry is the place where you could, if you folded it over, you would fold one half on.
And they would be the same.
Yeah, they'd be the same. Okay. The vertex. Okay, guys, just a minute, Brandon. The vertex is the highest. Wait, it's quiet. Okay. This I'm going to ask you in the classwork. There's 2 problems on it. Okay, guys. This is part of the learning objective here. The vertex is the highest or lowest point. We actually have a name for that. The lowest point we call the minimum, and the highest we call the maximum. And we care about that because when we have a parabola that we're modeling a missile launch with, we want to know where did it hit its highest point, maybe. Or if you're punting a football, at what time did it reach its highest point, and how high did it reach? Okay. Here we go. So if the value of A is, then put in there positive. You could put a plus sign if you want. Put in a plus sign there. If the value of A is positive, the parabola faces up, and the vertex will be a minimum. Okay, guys? I'm going to ask you to label the coordinate of the min or the max in the homework, okay, or in the classwork. So you just tell me what is the lowest point or what is the highest point on the graph. If the value of A is negative, the parabola faces down like this, and the highest point is the max. Okay? That's it. We're just classifying min and max. That's it. That's it. Ready for the next page? Yeah. Okay. So do you understand what min and max is of a parabola? Does every parabola have a min or max?
Yes.
And how many does it have? Yes, you're right.
I don't know.
1. It's either one or the other, right? Okay. Last one's here. Can you tell me what the max is of this right here? What's the coordinate right there? Can you tell? 3. So actually the coordinate would be 0, 3, and that is the max. Can you tell me what the min is here?
5.
I didn't see 5.
1, -2. No, 1.
It's 1, -1. It's this coordinate right here. You might be able to see it better on your page than on mine. So the max is this one at 0, 3. And then the min is at 1, -1. Okay, the last thing. This is it for today on these. Do you remember when you go back to lines, guys? How did we graph? Oh wait, that's fine. How did we graph a line the first time we saw them? You remember? You remember? Okay, that was actually the shortcut method. That was once we learned slope-intercept form. We even going back farther, I drew something that looked like this. What's this called?
Oh.
XY table or chart. Yep. So here's what I'm asking you to do on today's. I have 2 of them for you to graph. So today, I'm not going to teach you any shortcuts. I just want you to plug in the following 5 numbers. -2, -1, 0, 1, and 2. Think you can remember that? If not, look back at your notes. Okay, I'm going to show you how to do this. I'm going to move in just a minute. I'm rewriting it. I'm moving. Just a minute. Okay? So, here's what this looks like. To get the first term, you see this function right here. That's called a function. Y equals 2x squared. You see that? It tells me what to do with the x. Take the x. I didn't write that very neatly. Let's try that again. Okay. Actually, maybe I'll do it right here. 2 times -2 squared. Let's erase it here. Please just write it in the table. That'll be better. So 2 is in the equation, right? And then x squared means plug in -2. Anytime you plug in a number for a letter, you should put it in parentheses. Okay? What's -2 squared equal? No, not -4. +4. 4 times 2 is 8.
Ow!
Then do 2 times -1 squared. What's -1 squared, Johan? What's -1 squared? 1 times 2 is 3. Not 3, it's just 2. Okay, what about 0 squared? What's 0 squared? And then times 2?
0.
Still 0. What's 1 squared? 1, and then times 2 is 2. What's cool about these is they are symmetric. You're going to see that in just a minute. What's 2 squared again? 4, right? And then 4 times 2 is 8. So here's the great thing about these parabolas. I'm going to go left 2 and up to 8 and place a dot there. -2, 8 is right up here. Okay, do you guys see that? 2 left and 8 up. Then I'm going to graph the next point. What's the next point here? It's like -1, 2, right? Jose. Where are you going?
Get my balloon.
Okay, the next one is 0, 0. Then here's what happens, guys. It's going to go down to its minimum and then come right back up. So look at what the next point is. 1, 2. That's 1 over 2 up. Do you see what's happening here? It goes down, comes right back up, exactly across from where it was before. The next one is 2, 8. And then we draw a curve through these points. So I have 2 of these I want you to do on the classwork. 2 graphs by tables. I have 1 of each of these. Okay, 1 of each of those. And then there's one more thing on here. I think it might be on the next page here. This would actually be called a minimum. Where would the minimum be located here? Actually, I should have one more page here. I do, good. Okay, one more thing I got to show you. It'll be quick. You got all those points written down. There should be 5 points. And you're going to plot all 5 points. I'll finish this up in the next 2 minutes. I'm going to give you about a half an hour to do whatever classwork or retake you need to do. Anybody else? Well, write those points down. Yeah, write those values down. Okay. Those values down. Do you see how I got the values on the table? No? Okay. I plugged in each of these numbers under the x right here. So I squared them and then multiplied by 2 to get these numbers.
That's a long time.
Does yours pop up like this when it tells you this message? Our computer's just running slow. All right. Last thing on here. So I have 2 of these 6 problems. I'm asking you to do this right here. It's a real easy concept here. Okay. Here's the idea. The parabola gets wider as this number in front of x squared gets closer to 0. Okay? So you see how we have a -4 in front of this x squared? I'm going to stop here. I need everybody looking up here. House closed. Almost there. Okay, do you see how the -4x squared is skinnier than the 1/4 x squared? Do you guys see the difference between these two? Yeah. So as this number gets closer to 0, so if it's a fraction between 0 and 1, and it's getting closer to 0, it's going to make it wider. So of these 3, and I don't think we'll do this last graphing one. I think one graphing one with the table is probably enough. But of these 3, which one is the widest here?
widest?
First, second, or third? Middle, okay. So it says put them in order. So the first one would be 1/4 x squared. What's the next widest one of these three? Okay, this one? Okay, so x squared is next. And what's the skinniest one? The first one. Okay, so do you guys see that? Can you visually see that?
Yeah.
And do you see how the number in front of the x squared affects it? In absolute value, which number is the smallest number in front of the x squared? In absolute value. I have to say absolute value because this is a -4. So this one is the 1/4 is the smallest, and then 1, and then 4. Okay, so could you do that? Put them in order from widest to narrowest.
Yes, sir.
All right, that's it.
We're done?
We're done.